Hi friends, today I will be giving more details about Snubber, a special support power pipe systems in industrial use, why it is used, where it is used. Generally there are two types, mechanical snubber and hydraulic snubber, as you can see in the pictures. This detail is been provided by me. Let's look at the content. What is snubber? Why and when snubber is used? Types of snubber, selections of snubber, working principle of snubber, and finally advantage and disadvantage of snubbers. What is snubbers? Snubbers are critical support devices in a piping system which remain active in dynamic events, thus preventing the damage while allowing for a thermal expansion of pipe. So it comes into picture during the dynamic state. At the same time, it allows the gradual movement of thermal expansion of pipe. Now, what are the dynamic events? Dynamic events such as seismic activity, rapid valve closure, water hammer, or shock waves from equipment failures are controlled by snubber supports. So, during this activity, there are sudden jerk or displacement of the pipes. So, in order to hold those displacement, the snubber comes into pictures and it holds the pipe. Why and when snubber are used? At the dynamic condition, sudden jerk of pipe movement take place, which results in excessive stress in pipes and the associated equipment. In order to control both the thermal movement and the sudden movement during dynamic state, snubbers are used. So here, due to sudden jerk, the stresses are created in the pipe and the equipment, as well as the increase in other loads can also affect in the equipment. So just to curb this one, the snubbers are used. At the same time, it allows the thermal movement also. Now they are also known as shock observer, as they observe the shock, the sudden force which is being implemented on the supports of these snubbers. So are designed to control the movement of pipes and equipment during abnormal dynamic conditions such as seismic activity, rapid valve closure, water hammer effect, and prevent the damage caused by it. Now, types of snubbers. Generally, there are two types. One is hydraulic and the other is mechanical snubbers. Now, let's move to the selections of snubber. What are the criteria considered in the selections of snubber support? The first is the type. So, as we see, the hydraulic and mechanical based on the applications and cost. Second will come orientations and access. How the arrangement has been done for the snubbers and what are the access to be provided for it. Generally, for installation, we have to check the enough space should be provided for the snubber. Whatever the height is, the length is there, those lengths should be considered and should be checked that in the design that this space are available for the installations of the snubber. At the same time, the testing, for the testing also the space should be provided for maintenance access whenever there is any repairing activity to take place or to remove or to install it again back again. Those access should be available. Now the bleed rate, how quickly it return to normal after holding during shock. Once the shock is been like for some, this shock are temporary, it occurs for a few seconds. So once those shock has been come back to normal, those numbers should also get the activity that it come to the normal state. So that bleed rate, what how fast it how quick it will come to its normal position, that should also consider as one of the criteria. Then activation rate, here the velocity with this number lock, that is 4 per second here for example. So the activation rate, like for the setter, whenever there is jerk, how fast the snubber comes into picture to hold those pipe, that is also one of the criteria to be considered. Then comes dynamic load, ensure the snubber can handle the dynamic force which includes normal operating forces and higher during upset conditions like earthquake, relief fault, pop-up, water hammer. So here, apart from the normal operating force, the design force, whatever we are considering the calculations for the snubbers during the thermal expansion, other than that, the higher which may cause due to earthquake or sudden wall due to the sudden wall pop-up or any water hammer effect or any other unusual dynamic condition. So those force are also been summed up with this normal operating force, and that load has to be considered by these numbers. stroke, the snubber must be able to accommodate the total travel between the assembly and the extreme operating condition, sum of positive and negative thermal movement plus 20% anticipated thermal movement on either sides of the strokes. So here the between the assembly, that is where um, the cylinder or the edge of the cylinder where it can end, from there till the and the extreme operating condition, that is the movement of the pistons, those the total travel has to be considered. Here the movement of the pistons consider positive and negative both, plus sign and negative sign of the, that is the negative temperature as the positive temperature has to be considered in this calculations of displacement. Other than this, we have to consider the consistency of 20% anticipated thermal movement on either sides of the strokes. Now comes the space and solutions, the same what we have seen the first point, the same similar to that. Give as ensure the given snubber and its attachment fit within the available space envelope. To be checked. Now with the selection of snubber, when we have to provide data to the vendors in terms of the travel. So here in this picture you can see the data sheet has been prepared. We have just took some partial of that one, extracted this here, the extension, that is the travel distance, that is 75, which has been given the operating distance. Here we can see the compression extension. Here the negative displacement as well as the positive displacement has been considered, which are the max. So this will be summed up, and this is the lateral resultant, which has to be, which won't have much more impact here, but we have to consider that too, so that it won't we have to check the degree of the movement also. So this has to be given to the vendor for selection of the number. Here we can see the space allowed for the installation of the snubbers, the length calculated right from the structure's edge till the pipe's edge, or sometimes clamp if used it to the center of the pipe. So here the joint for the both side, like for the pipe which is getting welded to that and the pipe which is getting welded to the structure, both has been shown here and indicated here. Now let's go to the working principle of hydraulic snubbers. The basic working principle behind a hydraulic snubber is that under a slow speed, a piston moves within a hydraulic reservoir, pushing hydraulic fluid from the front to back and vice versa of that reservoir. So during the slow movement, that is during the thermal slow movement, we can say the piston moves, and here you can just see the reservoir, and here is the flow of the fluid take place. It will go from up, it will come down, again it will come here, again when the piston comes back, it will go from here to here. So the movement happens to and fro. So you don't restrict the flow of the, they restrict the movement of the snubber, and the snubber will remain active, that is it will remain deactive in terms of thermal movement, and the motion will be continuous. But when an impulse load occurs, sudden jerk that we call, the piston tries to move at high speed, a valve will close there by restricting or blocking the movement of the fluid within the reservoir and subsequently locking the moving piston. But when sudden impulse force act, and then the motion of the piston will be very speed, and this will create the high velocity in the valve. And if you see, the valve has got the less small orifice, that is the diameter is too less to allow the full flow of the liquid. So at that time there will be a stoppage of this valve. The valve won't allow to flow all the liquids through this small tube. So at that time the snubber will get rigid, and this will hold the movement of the pipe, and it will be considered to be active. So here you can see the reservoir, the cylinders, the pipe has been clamped over here, the lock nut, these all are the mechanical parts which is connected to it. That is the assembly of the hydraulic snubber. Now let's see the working principle of mechanical snubbers. The mechanical snubbers, on the other hand, uses a ball screw and ball nut assembly to convert the translational restraint movement to rotational movement. When the rotational acceleration reaches a certain level, the rotations of torque transfer drum is bound to steel by capstan spring. So here, if you just see over here, this translational movement is been rotated, is been give rise to the rotational of ball screw and ball nut. Here the ball screw is inside here, which you can see, and the ball nut over here. So this will rotate, comes into the rotational picture, and this, when the rotational acceleration is, when the rotational is too high, it reaches to certain level where the rotations of the torque transfer drum, which we called this as the torque transfer drum, is bound by still by capstan spring. The capstan spring will hold this drum, that is, it won't let the drum to move, to rotate further. And this, when the rotation stops, this entire rotation assembly will stop, and which does not give the movement to the translational. The translational movement also comes to a standstill, that is, become a rigid, and it hold the pipe. So that is how the function of mechanical snubbers. Now let's see the advantage of hydraulic snubbers. Reliability and durability. Features robust hydraulic system, self-contained reservoir to prevent leak, and durable seals for long service life. This is the first advantage. The second is dynamic protection, resistance sudden movement from seismic, water hammer, wall slam, thus preventing the catastrophic fall failure. So that what it does, it restrains the movement and save the pipe from a catastrophic failure. Thermal freedom allows pipe to expand and contract slowly due to the temperature changes without resistance, unlike rigid supports. So now, disadvantage of hydraulic numbers. What is that? Maintenance need, require routine inspection to detect potential issue, leaking fluids or loss of hydraulic fluid. So there can be chance of potential leakage which need to be checked with the maintenance need. Second, radiation limits and temperature sensitivity. The hydraulic cylinder may degrade in high radiation areas, making mechanical snubber preferred options. The performance and properties of hydraulic fluid can be sensitive when extreme temperature changes, which may affect snubber stability and functionality. So the fluid which is contained in the reservoir, it can change its property during the time of extreme temperature, high temperature, which may affect the snubber stability. So so there is a limitation for the snubber to be used in high temperatures. Next is the cost. The initial cost and potentially high maintenance expenses can make them more expensive. So there is a chance of it to get more expensive. Now let's go to the advantage of mechanical snubbers. Maintenance free. Mechanical snubbers are designed to be largely maintenance free during normal gradual operations because the braking mechanism is disengaged. So here normally there are not much maintenance to be done because it remain in normal in operation conditions only during, because it is the braking mechanism is always disengaged during this time, so there is not much maintenance to be done for this part. Second is high radiation zone and wide temperature area. Unlike hydraulics number, mechanical number can be used in high radiation zone because there is no fluid inside it, so there is no question of degradation. So they can operate effectively at a broad range ranging from 65 to 175 degrees Celsius temperature. No fluid leak, as they do not rely on hydraulic fluid. There are no concern for potassium fluid leak or need to routine inspection to check fluid levels. So there is no question of any fluid leak as there is no fluid inside it. Now what are the disadvantages of mechanical snubber? Potential for wear. While generally low maintenance, internal mechanical component, ball screw, capstan spring are subject to wear over a very long period. So this is generally because of the wear and tear. There are chances of the this kind of object which are installed in the mechanism to get wear. Second is no softening effect. Unlike some hydraulics number, they typically respond to accelerations by becoming rigid, which means they cannot soften load peaks that occurs during dynamic events. This can result in large unavoidable force peak being transferred to the supporting structure. So unlike hydraulics number, they eventually become rigid all of a sudden. Like in hydraulic, the rigidity do occurs, but it occurs soften. It soften the load peak that it doesn't at a time doesn't respond to the transfer of load so quick to the supporting structure like what mechanical snubber does. Response to acceleration. The activation's mechanism is based on acceleration threshold. So any gradual movement, even if substantial, will not be engaging in braking forces. So here the activation mechanism is based on acceleration threshold. Only when so any gradual movement, even if substantials, will not be engaging in braking. So if there is a gradual movement, the displacement do occur very slowly, or like any slow movement occurs. So there won't be any braking force applied on it. Suppose if there is a movement during the time of seismic activity, if the displacement do occur, but it occurred not so quick, so maybe gradually, so maybe more than thermal expansion speeds, but if we would go for that acceleration threshold which that for which it has been designed over here, so eventually the mechanisms number won't come into picture, that it won't be active, and there can be a loss in the when holding the pipe, and stress can be created in the dynamic conditions. So these are all the about the snubbers. Hope you all will understand, you will like this one. So keep watching my presentations. If any query, do let me know. Thank you.